Hi everybody, my name is Lucia Cangarova and today I would like to introduce you Automated Testing with Cypress. In this presentation, we will learn what is automated testing, what is Cypress, why we want to use it and its drawbacks. Additionally, we will cover a simple example showcasing how to get started with Cypress using a simple React application. Later on, we will see a more complex example of a Cypress test. We will learn about the projected capabilities of future versions and likely changes in the next few years. Lastly, I will direct you to further resources. So let's dive into it. What is automated testing? Automated testing is a process that validates if a software works appropriately and meets requirements before it is released into production. This software testing method uses scripted sequences that are executed by testing tools. Automated testing tools execute examinations of the software, report the outcomes, and compare results with earlier test runs. Test automation is the best way to increase efficiency, test coverage, and execution speed in software testing. Further, automated testing packages have built-in functionality for better reporting, improved bug detection, increased reusability. And let's be honest, no one wants to sit behind a computer to do the tests manually. In this tutorial, I would like to show you automated testing with Cypress. Cypress is a front-end testing tool built for the modern web. It addresses the key pain points developers and QA engineers face when testing modern applications. While this framework is relatively new, publicly released in May 2017, it's already building traction. What does Cypress offer? When compared to other automation frameworks, Cypress is more universal. That's because it is written in JavaScript. Cypress is usually compared with Selenium, another test automation framework, where teams can create robust browser-based testing automation scripts using a wide range of development languages. If you worked with Selenium, you know that before you start testing, you need to select all the dependencies and libraries needed for that suite of tests. But you don't have to worry about those things with Cypress. They're already set in place with no configuration needed. You can debug your web apps from Cypress quickly and easily. When tests fail, you get suggestions for how to fix the defect. Also, Cypress supports capabilities like time travel and real-time reload, so developers can examine their website code during test execution and after. And because Cypress has access to every object, it simplifies and streamlines error analysis. Cypress also can provide screenshots of test failures, which makes finding defects and debugging apps a lot more user-friendly. Cypress is known for its speed of execution. Cypress has automatic waiting built into the framework, which means that you don't need to define implicit and explicit waits. The framework automatically waits for things like DOM loading, animation, elements, and more. Also, after completing a test, the framework automatically runs the subsequent tests, which eliminates downtime and the need to manually trigger each test. However, there are few downsides of using Cypress. Because Cypress runs in the browser, it will never have multiple tab support. We do have access to the browser automation APIs to actually switch tabs, but there is no reason for us to ever expose them. If we want to test multiple tabs, it needs to follow a predefined test pattern, for example, opening a link in the same tab. Cypress supports only modern versions of web browsers like Chrome, Edge, or Firefox. Therefore, if an organization works with older versions of these web browsers for security reasons, we are not able to run these tests. However, Cypress provides an inbuilt web browser called Electron, which is downloaded when Cypress is installed. Lastly, the Cypress dashboard is a paid feature, so if we are on a budget, we may not be able to access it. However, in my experience, the dashboard is not a necessity to develop tests of a high standard. Today, I would like to show you how to get started with Cypress using React and Node.js. Node.js is an open source, cross-platform, backend JavaScript runtime environment that executes JavaScript code outside of a web browser. React is a JavaScript library for building user interfaces. So let's begin. To start developing Cypress tests, we are going to assume that we know how to write a web application in React. For this purpose, we need to have the latest Node.js installed. Then we are going to download Cypress via npm command, where npm is a package manager for JavaScript. After successful installation, we have to open or run Cypress in order to get the default folder to be set up. After running this command, we can see our folder structure appear. It includes the fixture folder, which should contain all our mock data. The integration folder includes all of our test files. The plugin folder includes additional implementations of Cypress that we can add, for example, pre-processing of files. Lastly, the support folder includes any additional support code, therefore this folder is run before everything else. For example, we can include here a command file which can hold our custom commands. When we run the command to open Cypress, we are provided with a Cypress UI, where we can manage and run our tests. We will learn how to debug and run tests with the Cypress UI later through a worked example. Let's look at an example of a simple test. This is how the UI looks like. It is written in React. The app contains a simple to-do list where we can add new items, mark them as completed, or delete them. At the bottom, we can filter our items and the number of active to-dos is displayed. The structure is similar to unit testing with JavaScript. Firstly, we have a describe function which presents a whole suite and includes all the tests. The describe function has a name, which in our case is list items, and another function which can include the before each function, test functions with names, the after each function, and more. The before each function in this example contains our custom function which we define in the support folder. This function mocks a GET request with our own data and visits our home page. One single test can be initialized with the it function, whose first parameter is the test name. This should be something descriptive, as in our case properly displays completed items. Then, the second parameter includes the functionality of the test. Our test gets all the to-do elements and filters them according to the class name completed. Then, it checks if the filtered elements are of length 1 and if it contains the string x. Lastly, it ascertains if the toggle checkbox of our particular element is checked. Here, you can see our Cypress UI. To run a test suite, we have to double-click on one of our test files. In our case, we click on the list items test. The Cypress tool runs all the tests in our file sequentially. In this example, you can see that our test case was not successful. The Cypress UI informs us what went wrong, and we can debug the issue. This is how a successful test looks like. On the left-hand side, you can see all the requests and commands that have been executed. You can see that the assert functions did not fail. A cool functionality Cypress provides is time travel, as mentioned before. For example, when you click on the command filter completed, the particular command is highlighted in the UI. With the UI, you can also see before and after screenshots, which is very useful when tests need to be debugged. So we've seen a small demo of how to get started. Now, I would like to show you a real app demo, which was created by Cypress developers. This application is a payment app wherein we demonstrate the real-world usage of Cypress, testing methods, patterns, and workflows. Here, you can see the Cypress UI again. The real app code has various test files, but for the demonstration, we will have a look at a single test file which tests creating new transactions in the UI. After running all the tests in the whole suite, we can see that they were executed successfully. Let's look at a particular test in this suite. For simplicity, I will just show you the flow of the test in the Cypress UI. Here, we are going to look at a test which should submit a transaction payment and verify the deposit for the receiver. Before the test, our before each function initializes the database, logs in a user, and gets data from the server. You can see this in the top left corner. Then, marked by the arrow, we get and click on the button in the top right corner, which is labeled as new. Here, I pin the command to click on the button, and on the right side, the screenshot shows the red dot where the test clicked. This screenshot was formed before clicking the button. This screenshot is after the button was clicked. Continuing, in the bottom left, we check that the balance matches our string pattern. Then, we create a transaction behind the scenes. Next, we get the Create Another Transaction button as highlighted on the screenshot and check if it is visible. Then, we check that our balance is not equivalent to the previous balance before sending the transaction. After this, we log out and log in as another user who is the receiver of the transaction we sent. We check if we logged in as the correct user. Then, we check if the list of transactions is visible. Next, we collect all the transaction items and check if there is at least one. On the right side, we can see that we have 5 transactions. Lastly, we check that the balance is as it should be. In summary, we can see the functionality of the test, and if we get an error at any point of the test development, we can easily find out what went wrong. Lastly, I wanted to show you that you can run your tests also from the command line. For this, you run the command Cypress run. In the absence of additional parameters, Cypress will run all the tests in our integration folder. On the screen, you can see a screenshot of a run of a particular test suite. These runs are same for all of the test files. After each test is run, Cypress records a video which shows executed commands. This is one of the benefits Cypress provides. It records videos even if we do not use Cypress UI, so we can see what went wrong if a test fails. Then, at the very end, Cypress makes a summary of all the tests and reports any failed, passed, or skipped tests. As in our case, all the tests passed successfully. As you write more and more tests, you will find yourself wondering, do I need to write more tests? Are there parts of the application still untested? Are there parts of the application that perhaps are tested too much? One answer to those questions is to find out which lines of the application's source code were executed during tests. If there are important sections of the application's logic that were not executed from the test, then a new test should be added to ensure that part of our application logic is tested. Computing the source code lines that were executed during the test is done through code coverage. Code coverage requires inserting additional counters into your source code before running it. This step is called instrumentation. Cypress does not instrument your code, you need to do it yourself. Therefore, for instrumenting the code, we will be using an additional package which can be downloaded via npm. In order to make sure that our code is instrumented, we have to run our application with an additional flag, so the instrumentation happens during the run. Moreover, the Cypress tool accesses our application with the instrumented code, and it is one step closer to generating a code coverage report. To handle code coverage collected during each test, i.e. counting how many times a particular line was visited, we have to add additional support with the Cypress code coverage package. It merges coverage from each test and saves the combined results. It also calls NYC, its pure dependency, to generate static HTML reports for human consumption. Therefore, we have to install more dependencies via the npm command. Then, we need to let Cypress know how we want to change its behavior, i.e. add additional functionality. Therefore, we have to add import statement to include support of code coverage package into our support folder. Finally, we have to register tasks in our plugin's index file. These tasks will be used by the plugin to send the collected coverage after each test and merge into a single report. When you run the Cypress test now, you should see a few commands after the test finish. One command saves the code coverage after each test. Then, after all tests have been completed, the second command generates the report. The final code coverage is saved to a NYC output folder. It is a JSON file from which we can generate a report in a variety of formats. The Cypress Code Coverage plugin generates the HTML report automatically. You can open the coverage index HTML page locally after the tests finish. When we open the index file, this is how the report looks like. It displays percentages of covered lines, functions, statements, and branches. If we navigate to one of the files, we can see which lines are not covered, displayed in red highlight. Lastly, the report also includes a count of how many times a particular line was covered. You can see this on the left side of the code. In conclusion, generating coverage reports can be sometimes tricky. However, in order to know if we covered all the code in our application, it is necessary. The future of integration tests is looking promising with innovative new options. I was already able to find modification projects of the basic functionality of Cypress, which makes Cypress testing even easier and faster. The community members are quick to respond, with many issues closed in the main Cypress repository. Furthermore, JavaScript has constantly been among the most used programming languages in this past decade, so with such a large target community, we can expect Cypress to rapidly become more popular in the coming years. As you can see on the graph on the right, over the past 2 years, Cypress download count has increased the fastest among a selection of automated testing tools. Additionally, I think more and more companies will start to incorporate Cypress into their software development lifecycle to raise the company's product values. Lastly, Cypress is currently exploring two additional features for code coverage during end-to-end testing. First, they would like to avoid the manual instrumentation step and instead capture the native code coverage that can be collected by the Chrome engine. Second, they would like to capture the code coverage from the locally running backend server that is serving the front-end web application. This is the server which handles the API requests from the web application. They believe that end-to-end tests with additional API tests can be effective and cover a lot of back-end code. In summary, Cypress is a fairly new testing tool which is used in cross-browser testing. If you are familiar with JavaScript, writing tests will be easy and the code is inherently readable and self-documenting. If you want to know more about Cypress, the documentation pages of Cypress are well written. You can find there lots of tutorials and examples. Usually, when we test something, we want to know the coverage of the test cases. Cypress can generate a test coverage report, which can be set up with only a few steps, as we saw in the slides before. Cypress can be integrated with a CI pipeline in the various CI providers like Docker, Jenkins, or WS. Additionally, I am adding here the two examples I have presented so you can have a closer look at the tests. Thank you for listening to me, and I hope I help you look into a Cypress testing world. Do not forget that if you get stuck, you can find lots of help from the Cypress community.